Okay, so thank you everybody for joining us today. So while we're waiting for others to join us as well, we're going to start the program. We understand the timing and also we're kind of Africans. We're mixing everything. We're trying to be on time always. So we're hoping that as people are joining, we're also okay. Yeah, we have more people now joining. So we'll have the recording as well on our YouTube channel always, as we'll do for every meetup that we're having. So don't bother. We're going to get that online for you guys anytime. So we're our ladies Abuja. So we welcome you once again. So thank you for joining. So I'll give a brief into who we are. So we're a local community of the Our Ladies Global based here in Abuja, Nigeria. So we try our best to bring up ourselves, encourage ourselves to learn R and use R in our work, in our personal projects in so many ways. We also mentor ourselves to help us get a little bit motivated to learn art. So we're not a kind of a separate group, but we're working together with the Abuja R user group as well to help ourselves, irrespective of our tribe, our states, wherever we are ready to help ourselves. So part of the things we do is that we have to have organizers that are going to help us to manage the group. So amongst us are myself, Belekesu Olatunji. I'm a data scientist based here in Abuja. So I'm also the founder and co-organizer of the group. So we also have Queenette Onwuka. She's a food technologist. We have Zinatuddin Mohammed, a public health she's a public health professional. So we have Ifeoma Egboha Ekwoga. Okay, we have so many local names here. She's an epidemiologist. Mabel Ajumobi, Abiodun Egwenu. These are also epidemiologists based here in Nigeria. Then we have Isikak Udo, who's a big data analyst. So we all work together to keep the group moving and getting speakers, coordinating ourselves, mentoring ourselves. So today we're going to be looking at easy code-based data visualization with tidyplots. So in this meetup, we'll explore the visualization of different types of data sets using tidyplots. So we'll cover the plotting of raw data points, amounts, and heat maps, as well as measures for central tendency, dispersion, and uncertainty. So we'll conclude by visualizing distributions and proportions and adding statistical comparisons and annotations using tidyplots. So our speaker today is Jan. So please forgive me. We are having issues with our own local name here as well. So, but I'll try my best to pronounce the name well. So we have our speaker here, Jan Broder Engler. Did I do it? I did. Okay, thank you so much. So, so Jan is a senior scientist focused on understanding how to keep brain cells healthy when the immune system goes into overdrive. So we just want to simplify what Jan does. So he works at the Institute of Neuroimmunology as a senior scientist. So, and multiple sclerosis. So he works at the Institute of Neuroimmunology and Multiple Sclerosis. So it looks at new ways to protect neurons from inflammation and slow down neurodegenerative diseases. So outside of the lab, Jan is passionate about making research more accessible. He creates open source tools like tidyplots and tidy heatmaps that help scientists turn complex data into clear, publication-ready visuals without heavy coding. So Jan enjoys sharing ideas at community events and bridging the gap between the cutting-edge neuroscience and practical data science. So whether you're curious about brain health, data visualization, or open source development, his insights spark great conversation. You can get more about Jan through his website. We have the link here, and you'll be amazed about so many researches that he has done. So we don't want to make it more kind of complicated by bringing in those technical details. But if you want to really know how amazing Jan is, you have to go to his website to see his work and his researches. So Jan, we're really honored to have you here join us today. So I'll give you the floor and you'll start the meetup today. So thank you so much for joining us.
Yeah, thank you very much for the kind invitation. I'm very happy to be here. And I try to share my screen. So can you now see the presentation?
Yes, we can see.
Yeah.
Please, can
Okay,
you confirm if you can see the presentation now?
Great.
You can
Okay, so my
send
idea
messages.
was to basically start with a little bit of a talk to give you an overview of what tidyplots is and how it can be used and what the ideas initially for developing tidyplots were. And in the second half, the idea is that I will open our studio and we can just go through a couple of examples for data visualization. And because we are not such a big group, you can always interrupt me during the talk. And in the second half, you can also ask me, maybe you have a favorite visualization that you want to do and want to know whether tidyplots is ready for the job or not. So then just go ahead and challenge me and tidyplots a little bit, whether it can help you maybe in your day-to-day work. So the title of the talk is Tidyplots for Easy Data Visualization. And the agenda is that I'm quickly going to introduce myself, what I'm doing on a day-to-day basis, then how data analysis workflows usually work, a short introduction into tidyplots, and then, as mentioned, a live demo. And then after the demo, I will give you some resources where you can find more information, how to use tidyplots and how to get started. And coming to the first part, so who am I? My name is Jan Broder Engler, and Broder is my actually the name I'm called by. And I studied medicine in Berlin. And since now more than 10 years, I'm a senior scientist at the Institute of Neuroimmunology and Multiple Sclerosis at the University Medical Center in Hamburg. So I'm exactly investigating how neurons react to inflammation and how they can be protected from inflammation. But also since a long time, since school, basically, I enjoy web design and programming. So this has always been the second half of my interest. And basically developing tools for data visualization brings this two worlds, so science and programming together. And also the web design has has a part that is more about aesthetics and visual clarity. And this is also something that I think is important for data visualization. So the two main tools I've been working on are tidy heatmaps and tidyplots. And the name tidy already implies that they are designed to work well together in the tidyverse. So when you have data sets in a long format, like they are typically used in the tidyverse. So coming from a research lab, I was confronted with data analysis workflows just on a day-to-day basis from a lab. And we have different machines like microscopes, plate readers, or flow cytometers, or imaging machines that produce data, and they are usually stored in some kind of tabular format. And to really make sense out of this data, generally a first step is to have this in a program like Excel, for example, and then to work with these data. So combine tables, copy and paste cells around, rearrange cells, apply formulas, maybe subtract a blank value or calculate ratios. And then sometimes you type in even additional information that is needed for your analysis. And then a typical workflow in my lab was to go to a dedicated data visualization software like Prism, where you basically take the data from your tables and then you paste this into this program, and there you do, again, reformatting, maybe transformation of numbers, and then you point and click in a user interface to compile a plot and finally export the plot to use it in a publication or in a presentation. And this workflow has several drawbacks. The first one is that it contains many manual steps. So basically, when you start working in the spreadsheet, in the Excel, then it quickly becomes, or can quickly become, quite messy if you tabulate stuff, and it's sometimes hard to reproduce what you actually did there. And also pointing and clicking together your plot is also not really reproducible, and also these software tools, especially Prism, are quite expensive. So this is repetitive, it's error prone, and it's also not really transparent. So therefore, in the lab, we started to adopt a workflow that is basically centered around R. And the goal for this was to have a more transparent, more scalable, and more reproducible workflow. And tidyplots was basically, or the starting point for tidyplots was because I was experiencing, when teaching people that come newly to the lab, how this R workflow works, that they sometimes struggle with the data visualization. And I was always thinking there might be an easier way, that it's not as powerful as ggplot2, which is like the main plotting library for R, is maybe not that powerful, but still can accomplish some of the most often used things in a more easy and more approachable way. So my goals for tidyplots was to have an interface design that is more intuitive than ggplot2, for example. It should be easy to use for beginners. Minimize the conceptual overhead. So in ggplot, for example, when you rearrange data labels, you need to know about factor levels and what they are and how they work. And this is a concept by itself that has a big value in R, but is maybe not strictly necessary to know about this, to just maybe rearrange your x-axis. And I was trying to maneuver around these concepts a little bit when they are not really needed. I wanted to have it aesthetically pleasing, and the scope was to have standard plots in life sciences because I come from life science. And this is all put together in an open source package that you can find on GitHub and that you can install from Khan, for example. And you have also lots of documentation online. I will also point you to some of these links at the end of the talk. And what tidyplots is able to achieve is a number of different kinds of plots, like in this gallery here. So it can do scatter plots and bar plots and area plots, heat maps, donut plots, and so on. And it works via a quite, I hope, simple and intuitive syntax. And this syntax consists mainly of 3 verbs, and these are add, adjust, and remove. So once you compiled your plot, so you decided what you want to have on the x-axis, on the y-axis, and for the color, then you use these 3 verbs to either add additional elements to the plot, to adjust elements that are already in the plot, so to change or twist them a little bit, or to remove elements that you do not need and that are there by default maybe. And this is an overview of the tidyplots workflow. So it always starts with a tidy data set. Tidy meaning that it's a long table format where each observation is 1 row and each variable is 1 column. And then the first function to be called is the tidyplot function. where you decide what to put on the x-axis, the y-axis, and on the color. And then you do the add, remove, adjust pipeline until you finally reach the point where you are happy with the plot and you want to save it to a PNG or PDF file, for example. And here in the middle, there's one example of such a data table where we have different groups. So this is a study where we have a placebo and a treatment group. And then there are high dose and low dose groups within these. And we also have a score that has been measured in response to this treatment. And the code down below then shows how we can take the study data set and then we can pipe it into the tidyplots function and say we want on the x-axis, we want to have the group. On the y-axis, we want to have the score, and the color should represent the dose. And what you end up with is then the plot on the right, where you can see on the y-axis have the score, x-axis the group, and the color represents the dose. And what comes then is a combination, in this case, of 4 different add function calls, all chained together with pipes. And the first one is to add the mean value of each group. And this mean value is represented by a bar, and the whole this bar is a little bit transparent, so it has an alpha value of 0.4. And this basically gives you this bar here that is shown in the background that represents the mean. And then after that, here the standard error of the mean is added as an error bar, which you can see here. And then the data points are added, so the individual data points per group, and also a test is added to compare the high and the low dose groups. And the result of this test here is represented as a p-value above this bracket here. So basically, by just chaining together this 5 commands here, you already get a plot that is quite far that you can already use it in a presentation or publication. So what different add functions are available? So they always start with these add word and then with an underscore, and then you decide what exactly do you want to add. When you want to add raw data points, then this is followed by data, and you can either add these data represented as points or as labels. For example, if you have different animals, for example, each animal as a data point, then you can also have the animal name represented as a label in a scatter plot, for example. Then you can add summary statistics like the count of the group, the sum of the values in the group, or the mean of the group, or the median. And then you can afterwards decide whether you want to have these represented as a bar, a dash, a dot, a value, a line, or an area. And examples for these are you can add a count as a bar, or a sum as a line, or a mean as a value. I will show you in the live demo how this looks like. Then there are additional add functions for dispersion. So you can add the standard error of the mean, the standard deviation, the range, or the confidence interval, and then decide whether you want to have it represented as error bar or ribbon. And then you can add statistical tests and decide whether you want to have it represented as a p-value or as asterisks. And of course, you can also here choose in the parameters which test exactly you want to use, whether this should be a t-test or a Wilcoxon test or something else. Then for distribution, you can choose to add a box plot or violin plot, and for proportion, there are bar stacks, area stacks, pies, and donut plots. And finally, you can add annotation like title, caption, but also lines, rectangles, and text. And everything is also compatible with ggplot2 code. So if you have something that cannot be done in tidyplots because it doesn't have the function yet, you can use the add function, and then within this add function, add, for example, a ggplot2 geom or a ggplot2 function. And then there are also heat maps, curve fits, and histograms. So once we've added all the layers to the plot that we want to use, you can also remove and adjust these elements. And the remove family of function is quite straightforward. They all start with the verb remove, and then you can decide what exactly you want to remove. For example, from You can either remove the entire x-axis, or you can remove the x-axis lines, the text, the labels, or the title. And you can also remove the caption or the legend title and so on. And the adjust family of functions are, some of them are dealing with a plot as a whole, so you can adjust the size. And this is also a difference between ggplot2 and tidyplots. Tidyplots always have a fixed size, so they usually start with 50 millimeters by 50 millimeters. And if you want to have them bigger or smaller, you can adjust the size. In comparison to ggplots, ggplot will just take up all the space that you give them. And they also, by default, do not have a fixed aspect ratio. So depending on your graphics device, they can be either square or landscape or portrait. And this is different with tidyplots. They always start 50 by 50 millimeters, so they are always square. And if you want to have something different, you have to use the adjust size function. You can, of course, adjust the colors, and I will also talk a little bit about color schemes. Then you can choose a different font and adjust the legend titles, the description, and the legend position. And you can adjust the axis and the axis titles. And the last part here is also a very powerful one. You can rename, reorder, sort, and reverse data labels or data levels directly within tidyplots. And I will show you how this works in the live demo also. And this makes it really easy to, for example, rename the colors in the legend without going back and playing around with the factor levels before starting the plotting. So this is again an example for the basic usage. So I start by loading the tidyplots library and then have the study data set. Type into the tidyplots function, decide I want to have the treatment on the x-axis, score on y, color should represent, again, the treatment. So this is basically the same information here. The color is giving the same information as the x-axis in this case. And then, as I showed you before, we add the mean as a bar, the SRM as an error bar, and the data points. In this case, as a B-swarm, meaning that if you have data points that would overlap each other here because they are really close together on the y-axis, then they are spread out to the sides to avoid overplotting. When you go a little bit more advanced, then you can create plots that are quite customized, like the one on the left side here, where I start with a data frame that contains the sales of cigarettes per adult per day for different countries. And here again, I put on the x-axis the year, on the y-axis the number of cigarettes that have been sold, and on the color I put the entity, which in this case is the different countries. Then I add a mean line here for each of the countries for the cigarette sales and reduce the line width a little bit to make the lines a little bit smaller. I add a title here and a caption, and then apply another theme to the plot that is not having just the x and the y-axis in black, but having gray lines representing the different breaks on the y-axis. And then I also adjust the y-axis to start at 0 and go up to 11. And adjust the size here to not have a square plot, 50 by 50, but to have a landscape plot. So the width is 100 millimeters and the height is 50 millimeters here. And then I can adjust the colors of the plot. And in this case here, I want to highlight 3 of the countries. So I give them dedicated hex values. So France should be in this color here, Germany in this, and United States in this colors. And all other countries should get the NA value, which is light gray. So they are basically just here in the background, and yeah, they are hidden by or they are just the background for these 3 countries that are highlighted. So then as a last point here, we can adjust the legend position to put the legend on the top. Usually it's on the right-hand side. and remove the legend title, which would be otherwise here, and then also remove the x-axis title, which was here. But since the title says this is the sales of cigarettes per adult per day, it might be justified to remove this here. Good. Last point before going into the live demo is color schemes. So tidyplots comes with a range of different color schemes, and there are two different kinds of color schemes. The first ones are discrete color schemes that you have for a number of categorical values, and the default color scheme is called colors discrete friendly, and was chosen in a way that it is optimized for people with color vision deficiency. But there are also additional color schemes like Seaside, Apple, Candy, and some more that you can use for displaying discrete values. Then some are color schemes for continuous values. Most of them come from the Viridis package, also making sure that they work for people with color vision deficiency. And the default here is the Viridis. And then there are a couple of diverging color schemes when you have a midpoint and then you want to highlight, for example, upregulation and downregulation in different colors. And down below are some examples here how these color schemes looks like. So there's one question already in the chat, how tidyplots integrates with Quarto. And usually it works quite well because tidyplots are basically ggplots. The only difference is that because tidyplots have absolute dimensions, so they have, as I said, they are 50 by 50 millimeters, you have to make sure that your plotting device in the Quarto document has the proper size. So you can do this by adjusting the figure width or figure height in the how are these called in the Quarto specs. So for each code chunk or for the whole document, you can decide what the size of your plotting device is. Okay. So since I started to answer the chat, I will, yeah, or go ahead.
Sure, we have some questions there. So should I read them out to you or you want to handle them?
I can also directly read them and
Okay, good.
answer
Yeah.
them as long as I see them here in
Thank
the
you.
chat.
Yeah, okay, thanks.
Tidyplots like ggplot seems not to be able to create interactive plots. Yeah, that's right. Can it also be integrated with Plotly, like transform ggplot to ggplotly? I'm not sure. So it's definitely not designed in a way to support interactive plots. You could try. So each tidyplot is also a ggplot. So you can try what happens if you stick this into Plotly, but I really haven't tested it, and it's wouldn't guarantee that this is working well. It's more meant to have static plots for papers and presentations. And how can you change the alpha of points? So usually you can just put the alpha parameter in the parentheses of the function. So if you have add data points, then you can add the parameter alpha equals 0.5, for example. And then you get semi-transparent data points, especially useful maybe when you have overplotting many plots on top of each other, many points on top of each other, and you want to have them semi-transparent. For learning purposes, is it possible to get ggplot2 code used in tidyplot for each graph? So yeah, this is not the way it works. I was also actually, this is a question I got a couple of times now, whether tidyplots is basically a generator for ggplot2 code, and then you can use the ggplot2 code. So this is all happening under the hood. So you do not get the ggplot2 code. So you just get the plot, and you can work with the plot and then also add additional ggplot2 components, but you do not get out the ggplot2 code. This would be quite tricky to do, actually. Yeah, so my next point would be a demo in RStudio. There's one additional question. ggRef or works with ggplot2 as an interactive function, but I'm not sure if it will work here because ggRef itself wraps ggplot2 functions for its interactivity. Yeah, I haven't tried this. What I have tried, so a little bit of interactivity, I wrote a script to be able to build up a plot, so interactive in a way that you get a plot where you basically see how the layers of information are adding up. So each line of code that is run changes the plot a little bit, and then you get a PNG for this. But this is a different way of interactivity. It's not in a way that you can hover with a mouse over a certain data point and that then get something highlighted or get additional information. Good. So I will switch to RStudio. Can you also see the RStudio window now? Is this, or are you still stuck with the presentation? It's working. Okay. Good. Then, yeah, I think I will just start with a few examples. So I just put some comments here to remind me what I could show you, but you can also interrupt me and say directly jump to this or that point, or maybe show me how I can do this specific visualization. Maybe because it was part of the talk, I will quickly show you these advanced plot that I already explained. So this is the one with the cigarettes. And I will just repeat this here and show you how the plot is changing when you chain these different functions together. So I will just start by using the dataset here and pipe it into the tidyplots function and basically just say what I want to have on X and Y and color. And the first plot you get here on the bottom right, this is a 50 by 50 millimeter plot, and you have on the X-axis the year and on the Y-axis the cigarettes. But the plot is completely empty because there's nothing added yet. So as a next point, when I now run one additional line, this add mean line, then you can see that I now get these mean lines for all the different countries, and I also get a legend on the right-hand side. And this is the standard color palette that comes with tidyplots, which is the colors discrete friendly. So I will include the next two lines, which is about adding a title and a caption. And then you see here, I now have an additional title and a caption. And now I change the theme also to this minimal theme, where I just have these gray lines for each break on the y-axis. And one thing I realize here that I do not like is that the 0 has a line, and then there is an additional line for the x-axis. And I would like to have not these two lines here so close by and close together. So I say that I want to start the x-axis directly at 0. And then it looks like this here, that the line is basically running over the x-axis and looks a little bit more clean. Next thing, because this is a little bit could benefit from having this a little bit more landscape, I make the width 100 and the height 50. And then I adjust the colors in a way that I only get dedicated colors for 3 of the countries and then a light gray for everything else. And then it looks like this here. Then I can make this legend here and shift it to the top. So it's now beneath the headline. And then I want to make the title a little bit bigger. So I adjust the title and adjust the font size to 14. So this gets a little bit bigger. And then I remove the legend title and the y-axis title, so the cigarettes here. And this is then basically the entire plot, the final plot. Okay. Good. So then next I would go to some more basic stuff. So I just load the tidyverse and here the tidyplots package and start with its study dataset. And this I already showed you. So if I execute here the study dataset, then down below, you can see that we have a placebo group and a treatment group. We have high and low dose, and we have these different scores here that have been measured. And so I will just take the data set here and pipe it into the tidyplots function and say I want, for example, the treatment on the X, on the Y, the score, and as the color, I want to have the dose, for example. So if I execute this, I get this empty plot here where I have treatment and score, but nothing yet on the plot itself. So basically the most bare-bone thing that you can always do is to plot the data points. So to plot all data points that you have here, then you can see, okay, I have 1, 2, 3, 4, 5 measurements in each of these different treatments groups. Some of these dots here are a little bit overlapping. So I might think about ways to avoid this overplotting here. One way would be to use the function bswarm, which spreads out the points here to the side. An alternative way would be like ask in the comments or in the chat. I can make the points a little bit transparent, and then you would see that some of the points are indeed overlapping here. And what I could also do is to surround each of the points by a white border so that you can, by this way, identify here points that are overlapping. I think I will go with a B swarm here. And then you might think about, okay, now I have these raw data points, but I want to have some kind of central tendency measure. So maybe I want to add the median for each of these group, and then you would just start a new line with a new add function and said, I want to have the median. And then here the autocompletion already gives you different ways how to represent the median. If you want to have a dash, a bar, a dot, a line, or the value, for example, you can choose to have a dash, and then it will draw a dash at the position where the median is. You can also add the median value, and this will give you the exact number or the value of the median in this case. Alternatively, maybe you want to use the mean instead of the median, and you get something like this. And together with the mean, it might also make sense to add the standard error of the mean as an error bar, for example, and then you get a plot that looks like this here. And a next logical step could be to say, okay, now I want to compare these different groups, A, B, C, D. Some of them look higher than others, so I might want to add a test to compare these and give me p-values for this. And by default, you then get comparisons for all possible combinations. But maybe in this case, A is really the control group, and it only makes sense to compare everything to A. In this case, you can just say, I have a reference group here, and the reference group is the first one. And then it will just give you the comparisons of each of the other treatments here to the control group, to A, and give you the p-value for this. And what kind of p-value is this actually. This is put in here. So by default, it gives you the p-value of a t-test that is not paired at that end, that is not adjusted for multiple comparisons. And in this case, this is the reference group is 1. This is something that we decided here because everything is just compared to the first treatment here to A. And yeah, I think this is for the study data set, just a simple example how this would look like. So I will have a look into the chat. Can you please show how to save the graph in a separate file? Yeah, this is something that can be directly done here. So if you just execute this whole thing here, then you get this plot. And you do not actually have to add an additional command, or you can still stay in the pipeline, so to say, and just say, now I want to save this plot. And I want to save it as my plot.png, for example. And so if I run this, then it still gives me the plot, but it also gives me the information that the plot has been saved to my plot.png. And because everything is in a pipe, you cannot stop there, and you can save this plot again, maybe in a different format. So maybe as a PDF. And if you run this whole thing here, it will give you again the plot and then save it as a PNG and as a PDF. And because this is part of the pipe, you can also take this save plot here, remove it from here, and put it up here. And what this does is that you construct the plot until this point here, which does not yet have the test p-value, and you will save this plot to my plot.png. Then you add the statistical information, this one here, and then you again save it as my plot PDF. So by this, you can basically save different stages of the plots. The first one here, if I go here, how they're called, my plot.png. So this one is without statistics, and then the myplot PDF, which was saved after the add test p-value. Oops, this is the PNG again. Here's the PDF. This one has the information about the statistics. Yeah, so this is a really easy and convenient way to save these to file. Good. So I do not see additional questions in the chat. Are there maybe additional questions from the audience, or should I just continue? Okay, yeah, then I guess I will just continue and look at my next topic here. This is R bar and area stacks. So for this, I usually use a data set that's called energy. Let's have a look what this is. So this is basically for different years putting together the energy source that has been used to produce a certain amount of energy measured in terawatts. And then the energy source is also categorized into different types. So fossil energy has the energy type fossil here, and then biomass and solar, for example, is renewable. So what we can do with this is we can pipe this into, again, the tidyplot function. Then say on the x-axis, maybe we want to have the year to see how the portion of these different energy sources is changing. And on as a color, I can then use the energy type. And what this gives me here is an empty plot as always. So I have to decide what to add and then add a bar stack with absolute values. So this is now giving me the energy types, but not across. Still have to put the Y here. So the Y is the energy. Okay. So now I have for all these different years that I put on the x-axis, I have the amount of energy that is produced by all these different energy types. And to be a little bit more specific, I could also, instead of the energy type, use the energy source, which is a little bit more fine-grained. And then I get all these additional information here, solar, wind, fossil, and so on. And in this case here, I use the add bar stack absolute. So these bars here should sum up to the total amount of energy that has been produced in terawatts, in terawatt hours. But I can also say I want to, for each year, want to have this normalized to 100%, so to have a relative representation. And then I get this year where basically each year is filled up to 100%, and then I can see for each year what percentage was contributed by these different energy sources here, for example. And something that's really closely related to these bar stacks here are area stacks. So I can just remove these bar here and replace it by area stack. And then I get a visualization that looks like this. Yeah, where you can also appreciate the contribution of the different energy sources. Good. Then I will go on also with categorical data with pie charts. And here I can use the same data set and maybe filter for a specific year. Maybe for 2023, see if this is working. Yeah, now I only have the information here for 2023. And then I can paste this into tidyplot and here on the y-axis, I again want to have the energy source. Now the energy and the color. Should be the energy source. And I can add a pie chart, for example. Yeah, and this is how it looks like. Now I only for the year 2023, I get the contribution of these different energy sources at a pie as a pie chart. I can also use a donut chart instead, which just takes away the centerpiece here, and then you get this kind of representation. And maybe at this point, I can also introduce the split plot function. You can also split the plot into different subplots. So let's say I'm not only interested in 2023, but I will also add 2020, 2021, 2022. So first have a look whether this is working here. Yeah, seems like it's working. So, and if I now execute the whole thing here, then it's basically giving me a mixture of all these different years represented as a donut chart, but I can afterwards say I want to split this plot by the year, which I should have 4 of. And then I get here these different years. This actually has 2 problems. So I will adjust the size. make it a little bit smaller to fit the screen. And so now it looks like this. Actually, this plot now has an additional problem that you might notice, which is here the legend. And this is something that is not yet sorted out in the current version of tidyplots, because it's basically making now 3 different legends, because some of these subplots contain just fossil and renewable and no nuclear, no other. Some of them contain all 4, and some of them contain all except nuclear. And this is coming from how it's currently set up, that this is basically based on the patchwork package, where this is a patchwork of different plots. And with a new version of ggplot that came out a couple of days ago, ggplot 4, I can now use also the faceting facility to make this plot. And then this problem here will disappear, but I still have to rewrite the whole split plot logic in order to work with this. And ggplot 4 is just a couple of days old, but I will do this, and then this problem here will be gone. Good. So not sure whether I'm going to go through all of these examples. Maybe instead you could just give me a hint what you're especially interested in. For example, from these topics, or another topic that you would like to hear about. And maybe also let me know what the time frame is. So are we, I think in the invitation it said we have 1.5 hours, is that right? Yes. Statistical comparisons. Okay, statistical comparisons I already touched upon a little bit. So this is what I have been doing here. So I will just copy this thing here to a statistical comparison and go maybe a little bit more into detail, remove the save plot here. And we get this plot here. So as I said, this is now a p-value for a t-test that is not paired, and that is comparing everything to A here. So you can customize this quite a bit. You can say, I want to use a different method. I do not want to use a t-test. I want to use the Wilcoxon, for example. And then it will give you different p-values and adjust here the method for Wilcoxon. You can also say, okay, now I'm conducting 3 comparisons within this one plot. So maybe I need to adjust for multiple comparisons. So you can choose a p-adjust method and then say, for example, I want to adjust using a Benjamini-Hochberg. And then it will give you again different p-values and say here the p-adjust method is now Benjamini-Hochberg. And yeah, this data set is not really suited for demonstrating the paired by, but you can, if you have a data set that is paired by a certain variable, you can use the paired by and then just type in the variable that you want to pair by. For example, you might have a batch that you want to pair by, or you have an individual that has been measured multiple times. Then you can say, I want to pair the test by individual, and then it will give you paired tests. Yeah, everything here that comes with a p-value is also possible to have it with an asterisk. So this is when you have many comparisons, maybe a little bit cleaner, and then it will give you, for the different significance values, different numbers of stars. So 1 star for 0.005, and then this would be 0.001 and 0.001 and smaller, the p-value. Then you can also always go into this function here and then look into the function documentation. And so I talked about the method and the p-adjust method. You can also have not only choose a reference group so that everything should be compared to one reference group, but you can also have specific comparisons. Maybe this is something I could also quickly show. By the way, you also here below you get some of these examples here. So I just quickly copy and paste this one here and put it here. So what this does is that it again adds a test p-value, but the comparisons are in a list, and then there should be one comparison between group 1 and 3 and one comparison between group 2 and 4. And this is basically 1 and 3 and 2 and 4, and you will only get the test results for these specific comparisons. Okay. Then I think I will move on. One other point in the chat is the reorder and customization. Maybe I start with the reordering. So when I have maybe a plot like this here, quickly grab this one, and now I want to okay, wait. Yeah, maybe like this, then it's less confusing. So I have A, B, C, D, and I now want to rearrange the x-axis here. So one thing I can do is I can say I want to just reverse the order. I can reverse the x-axis like so. And now I don't have A, B, C, D, but instead D, C, B, A. So just the other way around. But you can not only reverse, but you can also this here. You can also reorder the x-axis labels and say, I want to have D in front. And then you can just give this one level D, and then it should put you the D in front and it leaves everything else untouched, basically. But you can make this also by adding a C next. Now you have DC and then AB. And then, of course, you can add also then B and A, so to fully customize the order of the x-axis. And then there's something that sometimes comes in handy that is a little bit more automatic, and this is you can sort the x-axis levels without any parameter, and this basically orders them by in this case here by the mean value of the group. So here in this case, I had A, B, C, D, and now after ordering them by magnitude, I have A, B, D, C. And this can come in handy when you have multiple categories, like for example, in the energy data set, again, you have for one specific year, let's see if I quickly put this together. So I just have 2023. Won't do a split plot. And I want to have on X the energy type, on Y the energy, then add maybe a sum bar. So something like this. So now it's not ordered. You have fossil, nuclear, other, and renewable. And to put this in order, you just can do the sort x-axis levels, and then you will get nuclear, other, fossil, renewable. Okay. So what's next on the agenda? Customization. So customization is where did I have it? Custom styling. So the standard plot here, this one, for example, looks like this. So what you could do for styling, for example, is to adjust the colors. So just adjust color and then put a different color schemes. For example, a discrete color scheme like apple, for example, and then you get a different coloring here. You can also adjust the font, and here you can also put, for example, a different family. I'm not sure how the families are called. No, mono is not working. Korea is working. So now I changed the font family here. For example, you can also make it bold or whatever. You can change the font size to maybe 10. Would be a little bit bigger. Maybe a little too big. So 8. So basically, yeah, by using these two commands, I now create my own style. And what I now can do, I can also, when I have a style that maybe consists of even more calls that are chained together, I can make a separate my style function that is basically a function that takes a plot and then applies a number of styling functions like these two here. And then I can, when I have this plot here, I can just pipe this at the end into the my style function, and then I get the style applied to this plot here. And also when I have a different plot, let's say this plot here, now it looks like this here, and I can just in the end apply, or in this case, maybe before the split plot, apply my style. And then I get this also here. And you can even go one step further and can take the my style away here. And you can have a global option. Tidyplots options, where I have a parameter called my style, and then I will just make it my style. So what this does here at the moment, this is how the plots look by default, but then I can globally change the style, and then now all the plots that I do within these R session are then directly using this style that I defined here. And if I want to get rid of this, I just can call the title plus options without a style, and now it should go back to the default style again. So you can basically craft your own style, and then within these global options, yeah, make it your preferred style. And in the global options, there are a couple of other things that you can put in here. So you can define a default width and height if you're not happy with a 50 by 50 millimeter default. And you can also yeah, have a different unit if you don't like millimeters, or you can define a default Dutch width. Good. Then G2plot compatibility and heat maps and time series. So I will go with how does this work together with G2plot2? So if I have maybe I take this plot here again. I have a plot like this. And I have something that I want to add to the plot that I cannot currently do in tidyplots. I can always use the add function here. And then within the add function, I can use ggplot2 code. For example, I want to have a theme. I'll just type ggplot2 to see what's available here. So ggplot2, for example, has a theme dark. So I could apply this, and then it will just apply this ggplot2 function here. Of course, you can also add geoms from ggplot2, like, I don't know, geom bar. Okay, this is not working because it's only having X or Y. How is this other one called? Geom col. Yeah, so I can get rid of the sum bar. And now I have these geom col, for example. So I can just add ggplot2 code right here. Okay. Can we pass a vector to order? Okay. Maybe I do this first. A vector to order. So this actually I'm not sure about. Yeah, you can. I think this is what you meant. So the question was here down below, for the ordering, can we pass a vector to order? And what you can do is you can order by another variable in the data set. So these points here give you the, when you do the sort x-axis levels, you can put in another variable that's also present in the data set that should be used to order the levels. I think this should basically be what you were asking for. Or if it's a vector, I think that where's the ordering here again? Deleted it. Yeah, I think then I will leave it like that. So you can choose a different variable to order, and you can also within the reorder function you can put in a vector that you want to use for ordering. Good. Then heat maps and time series. So heat maps are quite straightforward. So what I could do here is I think there is a gene expression data set. So by the way, the data sets that I'm using here, like study, gene expression, and energy, they are part of the tidyplots package. And this is also a nice way when you learn tidyplots or when you teach it, that you directly have some data sets here that you can use to play around with the plotting without the need to load the data first and just to get started with the plotting. So this gene expression thingy here is that I have different external gene names, different genes, and then I have different samples, and then I have different expression values. So what I should be able to do here is to use a tidyplot, and then on the X, for example, I want to have the different the different sample groups, and then on the Y, I want to have the external gene name, and then for the color, this would be the expression of the gene. I can add a heat map for this. And yeah, what you can see now here is that you have all these different genes here, and they have different expression for these different groups here. And actually, maybe I could even, it makes more sense to put the samples here. Yeah, so now you have individual columns here for all these different samples. So they are from 4 different groups. 1, 2, 3, 4, 5 samples, 5 samples, 5, and so on. So what's the problem with this plot here? So one thing is that the y-axis label are overlapping. So one way to solve this is to adjust the size and say I want to still maybe have a width of 50, but I want to have a height of 100. So now I can actually read the different gene names here. And then some of these genes have quite high expression values, like the map 1 here, and some have quite low, like this one below. But maybe I'm more interested in the dynamics of each gene across the different groups. And what I can do for this is a z-score by row. And this is possible to do directly within the heat map. I can scale by row. And what this does is that it basically takes, a little bit simply speaking, the maximum and the minimum value in each of the rows here and gives the highest value the red color and the lowest color the blue, the lowest value the blue color. And then you can now better appreciate that, for example, the VGF is upregulated in this group here and in this group. And the Elmo2 is only upregulated in this group, but not in this group and not in this group. And with the visualization before, the information is also there, but it's much more difficult to see this without the row scaling. Yeah, I think in the gene expression, I also have additional information about the direction of the change. I have here this immune gene, and I also have the direction. So I could order the genes here by the direction, whether they are up or down regulated. So I can sort the the y-axis levels by direction. So in this case now, I'm not just, when I do this without direction here, it orders the y-axis by the highest values. So, and as we have seen before, this gene here has the highest expression value, so it ends up at the top, and these are the low expressed genes. But if I put another variable that's also in the data frame here, the direction, up or down, it now sorts the y-axis levels by this additional variable, and then I see that half of the genes here are upregulated in this second group here, and the other half is downregulated here. Yeah, I think this is it about heat maps. And there's only missing the time series, which is default resolution in saved plots. Yeah, this is also something I can talk about. First, so what's the resolution? And maybe the heat map is also a good example here. Sometimes, so if I save this as a PDF, heatmap.pdf, like so, then this has no resolution because this is a vector graphic. Oh, by the way, this looks interesting. Okay, I was going to talk about rasterizing. So you can decide to rasterize, but the default is that it's not rasterized. And then you can also decide a resolution. So you can have a higher resolution that looks like this, for example, or you can have a quite low resolution, and then it looks like, okay, I have to get the rasterize also. Rasterize. Ooh. So now I said, okay, I want to rasterize the heat map, so make a pixel image out of it, and I choose a rather low resolution. So what could be a reason to do this in the first place? Sometimes when you have really, really big heat maps, then all these vector shapes here that you get at some point will slow down the performance of the PDF. And this also happens when you have lots of data points for a scatter plot, for example. And then you can say, okay, I want to rasterize the data points, or I want to rasterize the heat maps. And then everything else here in the plot stays vector information, so sharp and crisp, no matter how far you zoom in, but this information here gets rasterized. So yeah, there's the default resolution when you save something as PNG is the default resolution that comes from the device, and then you can basically also here should be able to change the resolution. That should actually actually not sure if it's called resolution or DPI. Just try it. Oh, yeah. So this is now the default. And if I want to go lower, maybe I try dots per inch. Dots per inch by 20. See what this does. Yeah, this is now really low resolution plot. So you can still stick it into the save plot to affect the whole PNG. Good. Then quickly go through time series. And then I think as a last point, we'll, or maybe here the last question was, is it compatible with ggplot2 extensions like Grid Extra? So I'm not sure about Grid Extra actually, but everything that works with ggplots also should work with tidyplots. The only thing is that if it's reliant on the plots not having fixed dimensions, then you could run into problems. Actually, you can also change this default behavior. So if you have a plot like this here, where you have a 50 by 50 millimeter, you can adjust the plot size. And say the width and the height should be NA and NA. And what this does is that it restores the ggplot2 default, that the plot is basically taking up all the space that's available. And the graphics device here defines how the plot in the end looks like. So in tidyplots, I choose to fix this because yeah, depending on the graphics device, the plot looks completely different, and the ratio between font size and the bars is completely arbitrary. And therefore, I decided to go by this here. And this is actually causing the most trouble for people using tidyplots because they are used to the ggplot default, and also Quarto and Shiny are kind of yeah, used to having flexible dimensions. So if you need this, then you can always do these adjust size and A to get the flexible dimensions back. Okay, I think I will quickly switch back to the to my presentation and just go through the last couple of slides. So we have done the demonstration. Maybe one thing before that, you can always head to the tidyplots.org website. There you can see, you can read the paper. You can click here to get a link to the ggplot, to the GitHub page. Also, there are more examples where you can just click here and then you get a use cases page where you have a number of different plots. For example, this one here that I showed you, and you can just click on this little show code here and then on this copy. And now I have copied the source code that is needed to generate this plot here. And you can just put it into your RStudio session. And then if you want to reproduce this plot here, just go here, click, and then it should run. So it reads the data from the web. So you do not need anything else. You just install tidyplots, and then you can reproduce all these different figures here by just copying the code and then adjust this to your needs, or use it as a template as a starting point. Okay, then going back to the talk here, there is a package index on the website. You can also always look into the help functionality within RStudio. There's a cheat sheet also that you can download with all these different functions, like to have an overview. There's the tidyplots paper where you can read more about the design decisions and also programmatically how tidyplots is set up. And yeah, there are a number of resources, tidyplots.org or /use cases, social help, or cheat sheet to get the cheat sheet, for example. And if you use tidyplots and you like it, to support it, you can, of course, cite it in your published work. So if you have a paper, you can cite the tidyplots paper. You can leave a star on GitHub. This is also helpful to show that the package is useful, and you can, of course, ask questions or request features or contribute code on GitHub. And I will then try to implement your feature requests, or if you stumble across a bug, then I can try to fix it. Yeah, and with this, I would like to thank you for your attention and some acknowledgements. This are all the people that are working in the neurobiology lab I'm working in, and Manuel Friese, my boss, gave me also the chance to work on tidyplots, also partly during my work time. So this is much appreciated. And then my office neighbor Lars is always giving me input on how functions should be called and whether this is intuitive or not, and also gave yeah, lots of helpful comments how to make this a bit better package. And with this, I would stop the screen sharing and be open for questions if you still have questions.
So it's been a wonderful time. It has been an interesting session. Thank you so much for your time. So, and we're really grateful for the intensive deep dive into your package. So, if we have any more questions? Yeah, this is an amazing talk. So thank you so much. This was a wonderful session. So for all of you that are joining us today, we are going to have the recordings shared on our YouTube channel. We're grateful for your presence here. We appreciate you, and we're looking forward to a next time that you will join us. So before I would want to round up completely, I want to really appreciate Queenette for getting us Jan to join us today. It's rather unfortunate she's sick now, and we're wishing her a speedy recovery. We pray that she will get well soon. So, well, I want to thank you, Jan, for joining us. Thank you so much. We appreciate it, and we are really honored to have you. Thank you so much, and we look forward to next time having you here. Thank you so much, and we're wishing you all the best in your packages, the development so far. I really had a wonderful time too, working with the Aropos side. And I did a good motivation for me, and I believe I can do more. Thank you so much. So back to everybody, thank you for joining us, and we look forward to having you next time. So bye.
Thank you. Bye bye.
Everybody. Bye.